leaders in the world. Coming today to us from Toronto, Canada, we have Bill Wong with us. Bill, what a pleasure to have you with us. Bill is going to discuss the AI-powered digital transformation in healthcare. Now, Bill is an AI and data analytics practice leader working for Dell Technologies, responsible for Canada. He's coming today from Toronto. He has been directly involved with a number of universities and hospitals to help them define their AI strategy and deploy a platform to accelerate deployment of their AI applications. He has authored a number of books on data analytics and data management, including a book focused on bioinformatics and a quarterly AI newsletter focused on healthcare and life science industries. So, ladies and gentlemen, please welcome Bill. I'm going to leave you in his very capable hands and guidance. Bill, it's always a pleasure to be with you. Thank you for taking the time to sharing your expertise with our audience today.
Thank you, Jose. And hello, folks from Toronto, and thanks for joining. And my heartfelt thanks to all of you in the healthcare profession for keeping us safe and healthy during this time. As Jose said, I spend a lot of time in AI. I'm a bit of a data geek here. Do this all my my full-time job, my spare time, and I really enjoy the time I spend in healthcare because I feel that this is where technology really makes a difference in people's lives. And I'm excited to share with you some of the things that we're seeing today. So I'll give you a kind of quick update of digital transformation efforts in healthcare and share with you a survey that we've done worldwide, the current trends in AI, and focusing on both the hardware and software and solutions that we're seeing out there. And then with the time left, we'll talk about deployments of AI applications and best practices and touch on multi-cloud deployments. First of all, I'd like to say a little bit about Canada and AI. Canada, we're well known for kind of being kind of quiet, but in AI, we're a bit of a player here. If you followed AI and the kind of big boom, as people call it, was really at the University of Toronto in 2012 with the ImageNet conference. And since then, Canada defined kind of a national strategy for deploying AI and to give incentives to startups there. And we were the first nation to develop a national AI strategy. There's last count 32 nations now with a national AI strategy. That's how important a lot of countries view AI. And if you take a look at some of our leaders here, Geoffrey Hinton at U of T, often referred to as the godfather of AI, Yoshio Bengio at University of Montreal, and the lead researcher from Facebook, were all awarded the ACM Turing Award recently. And that's like the Nobel Prize in AI. And they all have studied in Canada. Two of them still in Canada. Yoshio did his postdoctorate here. So we're big into AI. We really think it is a game changer out there. Every 2 years, Dell does this worldwide survey with 4,300 of its customers that they engage with across 18 industries. And the survey asks them several questions, but regarding on where you are in this path for digitizing your services, or what we call digital transformation. And I have to admit, when it comes to healthcare, a few years ago, healthcare kind of lagged in the adoption of technology. And if you can see here on the bottom left-hand corner here, in 2016, like 17% of people we surveyed consider themselves laggards. That they were quite happy just to sit back and watch everybody else adopt new technology. They had no incentive to kind of really adopt technology to improve productivity, etc. But now, fast forward to today, healthcare is leading the world actually in digital transformation, and people who view themselves as laggards, it's under 5%, it's just a mere 3%. That means the population, all these industries have moved over more into evaluating digital technology and adopting it. So healthcare, outside leading, has also been one of those industries that have had investments increase during this time. I'm going to touch a little bit about both healthcare and life sciences. And if you're interested in this survey, you can contact me on LinkedIn or go to Dell and do a key search on Digital Transformation Index, and you can get the full survey here. So in public and private healthcare, some things I'd like to point out here, some of the barriers for adopting technology. And on number one, you're going to see is the ability to extract insights from data. I think everybody in healthcare would agree that it is one of the most challenging environments to leverage data. There are just so many different types of data. I remember when we were doing research with one of the life sciences researchers in healthcare, the data is so siloed, and even when they did their research data, I saw some researchers develop their own data types at the time. This is back in the day, if they didn't have a data type that was suitable. And because of that historical context, it's very challenging to leverage data in healthcare. Lack of data privacy, always an important thing. Lack of budget is less in healthcare than what we see globally in other industries. One thing I'm happy to report here is that there's a large confidence, high degree of confidence in AI and leveraging data to support healthcare workers in responding to the pandemic. And so you've seen, and I'm going to share with you some of the technology advances that have been made possible with AI. Now, life sciences or healthcare research, not surprisingly, their ability to extract insights is ranked number 3. It's not number 1 because these folks typically have more subject matter experts who can manage the data here. So for them, the highest concern is privacy and security, as it should be. Now, across the industry, not just in healthcare, the C-level executives view AI and analytics as the big game changers that can really change the way they do business. And because of that, if you take a look at investments in technology, especially in the back end of the data center, this area of technology, analytics and AI, is the fastest growing area of investments. So it's growing at plus 25% per year. Now, healthcare, there's this hype cycle I like to use when I talk to people in healthcare. And like a lot of new technology, there's this thing what we call a hype cycle. So on the far left here, these are technologies that are just coming out or perhaps hasn't matured yet in adoption. So there is computer vision applications, and you're going to see more and more of it. But as you go up the curve here, at the height of hype, right now, there's a lot of people talking about augmented reality. I have one hospital I'm working with. They want to equip everybody with these Oculus visors to help them perform operations better. So there's these aspirations. Now, before previous years, you had things like CRISPR, AI was back there as well. But over time, as technologies mature, you see them go down the curve, and some really drop down. So at the bottom here, like Internet of Medical Things. So there's a lot of promise of that, and there still is, but I think people have got their expectations at a more reasonable level of what is possible. And then over time, what you see in the curve is it levels off of what is possible. So one of the vendors, I'm not going to name who, but you know, they would claim AI was going to cure cancer. And while I think it has that ability, I think you have to kind of set expectations that it isn't going to happen overnight. Now, when we get to the hype cycles of technology here, the same thing is happening here. So there's a lot of new technology. It's like the Wild West AI right now. We'll touch on a number of these, but over here, the one that's matured, people have reasonable expectations about it, is a GPU-based processors to power AI applications. And here on the right, emerging technologies. This is Gartner, where they identify, well, in this year, they identified kind of the top 30 applications out there that people are all excited about. And well over a third of them are AI-based. Now, these pictures down here, this is what they call generative AI. And unfortunately, generative AI has kind of can have a bad use. Generative AI is can create things like fake news or deep fakes. And this diagram here is the evolution of deep fakes when it comes to creating images. So the pictures that you see down here, none of these people are real. This is AI creating that. Now, there are some benefits of this. In healthcare, we worry about privacy a lot. But wouldn't it be great if we could create sample representative data and they really didn't belong to anybody, but we could use it for development purposes. So areas of technology to watch. And as I work with healthcare institutions, generally what I see driving AI are one of these big kind of drivers here. If there are other ones, I'd certainly like to hear about it, but on the far left, most everybody agrees that the patient experience is very important to focus on. And see a lot of hospitals and research centers focus on precision medicine, so getting very personal on the recommendations here. Lots of researchers are looking to use AI to advance research, and we'll talk about that in a second here. Reducing time at hospitals, reducing costs. Patient length of stay is a KPI that I see often. And then finally, bigger things like population health, SATs, government agencies are looking at right now to use AI. And here are some of these applications, and we're going to take a look at some of the specific ones that we've seen here in Canada. Internet of Medical Things here. Again, I see a lot of hospitals looking at, especially at the last one here, on remote medicine. Precision medicine, now back in the day, this was always going to be like in the next 5 years, but there are reasons for us to believe that it will be in the next 5 years. And when I said the next 5 years, that was like 20 years ago. So there's always been this hope, and I think we're getting close to that now. Hospital operations, and again, public health here. So let's step back and take a look at these technologies here. And most of you probably recognize these icons, except the one here down the bottom. And that belongs to a company called GraphCore. And GraphCore is a startup here. You'll see them on the right. I'll talk about them in a second. But the spectrum of compute solutions that people have here on the far left here of your screen, you can see CPUs dominated by Intel and AMD. But where NVIDIA has gained prominence is its use of the GPU. So thousands of cores here. They're the 800-pound gorilla in this marketplace. Have done very well. FPGAs, field programmable gate arrays. These are more flexible processing chips that you can recode at the firmware level, represented by Xilinx and Intel. And then on the far right here, you have ASICs, or application-specific integrated circuits. And these are chips that are specially designed to do AI, specifically deep learning type algorithms. The advantage of this is it should be cheaper. It should produce less heat, but on the price of that is that they're so specific. You can't run spreadsheets or databases here. They're primed to do just those functions there. Excuse me, but this is where all the startup capital is. So you're going to see medical devices, smart medical devices powered by these kind of chips in the not too distant future, if you haven't seen some already. Now, one trend that we're seeing in the industry, and I'll talk about a couple examples here after this, is the merge of AI and what we call HPC data analytics, or HPDA. And HPC analytics is typically simulation type workloads or Monte Carlo analysis, where you throw tons of processing power to these models that humans write. Now, what we're seeing is that in a lot of research, especially in healthcare, it's not so simple to throw an algorithm and problem to solve. So even with the COVID, the molecular structure of COVID was discovered using a lot of AI technology here. But before they actually define the shape of the molecule, they use AI to predict what that shape might look like. And when they took that prediction and at the same time used that in their simulation model to test possible vaccines to see if this would dock. And when I say dock, that would mean preventing the virus to take action. And let's see here. Maybe experience network connection. Okay. So, and so what we're seeing here is this merge, and this is not just in healthcare. We're seeing this in other industries as well. Is that you need many different types of analytical techniques, AI, simulation, to solve your problem here. And at Dell, I believe we're still the first and only provider that can provide a platform that can merge these environments together. So on one hardware platform, you can do simulation, but also do AI versus having two separate siloed environments. And so this university, UBC, and its affiliation with the Vancouver Prostate Center, I've had the opportunity to work with these researchers for many months, and I still meet with them every 2 weeks to kind of talk about their progress here. And what they're doing with AI is really trying to transform how they do molecular docking. So if you're in healthcare doing drug discovery, forgive me for my simple analogy here, but docking, think of the space lab out there. When we send rockets up there and they try to dock, and when they dock, it's quite secure so that the astronauts can get into the space station here. And so the concept of docking, molecular docking, is you want to find a virus that has a really good fit to block the activity of the virus. So the challenge here is that there are billions of possibilities for finding a molecule that perhaps may block the activity of a virus. And that's a challenge. And that's why drug discovery takes on average 12 to 15 years. Now, what these researchers have done is they have a campaign they call to assess and test 40 billion molecules as possible drug candidates. And what they've done is they used AI to predict, to reduce the possible molecules that they would actually have to go to the lab and physically test. And they have saved, in working with us, 10 years. And docking has reduced 5 billion molecules, 40 billion. Anyway, the reduction in the amount of time it took was just 10 days here that we were working together. So this researcher who I work with will be presenting this at future Dell conferences. If you're interested in this, number of papers have been written here. And what they've done is the combination of molecular docking and deep docking, they've coined this term, molecular docking and deep learning, they coined this new term, deep docking. So a very, very interesting way of using AI that we hope will transform how people do molecular docking. Their vision is to create a docking platform so that all researchers can go to their site and get access to these kind of resources at, I believe, at no charge, all right? So something to look forward to there. Now, in developing AI applications. There's lots of solutions out there. And again, a bit of a wild west here. These really haven't settled down. You see wild shifts in where these vendors are. But for the first time here, on what you see on the left here, this is the first time that they've compared AI development solutions from the cloud vendors, the hyperscalers we call them, Microsoft, where's Google there, and Amazon. And interestingly enough, despite the size, the depth and breadth of all their products, they put these products, I would categorize, in an important quadrant, visionary, but they're not the market leaders. They're not the market leaders who are developing the more innovative applications. Not to say they don't have their share of great customers doing great things, but people are advancing their AI algorithms faster with some of these other solutions that you have there, which are typically on-prem. Personalized medicine. So as I mentioned before, this has been something that a number of folks, including myself, have been chasing for a number of years, and how challenging it is. This figure has been used by many researchers here, about 2,314 exabytes of healthcare data as of 2020, and it's still growing at over 40%. It's just massive. And then on the left-hand here, the genomics type-based data, and then the clinical data, and trying to merge these data types. If you've done this, my hats off to you. It is so hard. The integration challenges here. I know some of my colleagues say that financial service telco has equal challenges. I still think the most challenging integration of data that I've ever seen is in healthcare. A lot of it here, a lot of it's error prone, so siloed. All the vendors out there, the kind of what I would call the legacy type vendors, have always dealt in proprietary data, never interested in sharing. These are some of the challenges that we have. And the best practice to help try to address that is to build a data platform. Some people may call this a data lake. And to take data, again, regardless of its form, to ingest it into what we call a landing zone. And there we would transform it, make it usable, put in a curation zone in the center there so that people that we have on the far right here can get access to the data. I'll share with you kind of our experiences that we're doing this with a research hospital in Toronto at this time. Now, I should say that of the data types I've seen to be leveraged in AI, I think genomics, electronic health records, and then image data are probably the top 3 data types. So here's some applications that have come out relatively recently. Not surprisingly, this first one, thermal vision detection. So during this period of the pandemic, this is the ability for thermal cameras to, with pretty good accuracy, determine the temperature of people going by. I mean, people would question, does that really indicate if they're a carrier or not? But yes, we could argue, debate that, but at certain temperature ranges, certainly they should be flagged. And this technology, you can be rest assured, you have options to redact faces. A lot of computer vision applications are reassessing on whether or not to capture those things, and this application does that. Now here's something that's a little more kind of cutting edge here, the second one on cancer diagnosis. On full disclosure here, IBEX, this is a company, a startup company from 2018. Dell has provided seed money to help them get off the ground. But they're one of the first that I'm aware of to take, to try to take digital pathology and use AI to help clinicians with their assessment of these biopsies. So I understand now that they have production pathology labs in production in North America, in the United States, in Europe, and in Australia. So it's really exciting technology here. And let me see if I can see that diagram here. So on the right here, this is when you place, create your slide, that's typically what the clinicians have to look at. And the diagram that here you see on the right here, this is the AI program color coding the possibilities of cancer existing. So they're very simple to assess versus taking a look at something like this. Now, what's interesting about this technology, and I'll get that to the next screen. First, just want to mention that we have 3 labs around the world to help our companies who are developing computer vision-based applications to test all these moving parts together. Now, this slide was shared at the recent Spring AI conference at Stanford University. So I was participating in that. And what makes this interesting, a couple of things. They highlighted this, so there's a lot of discussion about this. I'm happy to report that this study was actually done in Toronto. So again, even though we're not the biggest economy in the world, we're really big in AI here. And what they did was they shared images, X-rays, chest X-rays, to what they called the radiologists, and they were the deep subject task masters. They're the experts. And then we had regular doctors there. They're good, but not as good as the radiologists here. And what we found is when they assess the quality of advice and diagnosis, that the radiologists were the group that said, hey, whoever made this diagnosis, they would give the poorest rating if it was a misdiagnosis versus with the doctors. They couldn't really tell just, or didn't have that strong opinion say that was really poor quality. But what was also interesting here is on the right-hand side here, is when you asked the radiologist and you told them this diagnosis was done by an AI program, this diagnosis was done by a human, the radiologist would rate the human higher than the AI program. And so it bodes, I think what we take away with that is, despite how good the technology is, we can't take the human out of this. That I think the more mature companies who are delivering AI applications recognize that we're trying to augment humans in how they perform their tasks versus then replace them. And I have to admit, I asked myself this question too. I've worked with a lot of AI programs, and some of them to try to replace the tasks that I do. And I'll have to admit, I'm quite critical. When I see an AI app, and I know, and I see its prediction, I'm very critical, and then say, oh, it's way off. It's way off, right? And I probably do give more leeway to the human. But I think over time, that's going to change because the solution I showed you before, IBEX and cancer diagnosis, it was in their studies, and it's getting better over time with more data. It was accurate over 99% of the time. And humans, they can't match that over time. So watch this space. It'll be something that will continue to evolve. Okay. Now, a lot of companies, and particularly the cloud companies too, are making recommendations about their applications and saying cloud first, put everything in cloud. And I have met many companies who are doing that, and those same companies, usually a couple years later, are saying, time out, we're finding that, yes, cloud is great for helping us deploy applications faster, but we're spending more money here. So they're reassessing, is it really worth it? And for those companies who are taking a pause, what they're finding, and they're kind of rejigging their perspective, is perhaps rather than just saying cloud first, let's think about it. Does it make sense? Is this the first best place for this application to live? So from a business perspective, let's take a look at, how we use the data. There's a large amount of data. We're talking petabytes. Do we really want to put that up there and then transfer data, or leave it up there when cloud vendors will charge you on the amount of data that they ship you? So it's a complicated question here. But in healthcare and life sciences, at least in Canada, I will tell you that we're the dominant player out there. Most of the data out there for healthcare research, it's on-prem. I'm not saying that there's no place for the cloud, and I think cloud for perhaps the development purposes, but for production, for privacy, at least hospitals and life sciences firms here, much more comfortable with that being on-prem. This slide I've showed with Jose for a little while, and last year, or actually a few months ago, Oracle was viewed as number 4 in public cloud adoption. And now, as I predicted, Dell's VMware cloud is now number 4. So who would have thought in that short of time? So the major cloud vendors, Amazon, Azure, Google, but now many people are looking at what does Dell have to offer in the cloud. So VMware virtualization solution is available not only on AWS, but we do have hybrid solutions that play well with Google and Azure. And for that, I've created this slide if you are interested in developing hybrid applications, especially when it comes to AI and data analytics. Here's all the kind of offerings from AWS, Azure, Google, from Dell. And to keep everybody honest, I've listed the open source options as well. Now, as everybody's moving toward as a service, and that part of the cloud is good, let's try to make everything self-service. Let's try to remove IT where in the past they would actually delay things. Hopefully what they do is provide an environment to let the end user drive the development of models. So here on the left-hand side are some of the challenges that we have, and I'm working with a hospital who have this problem, actually another healthcare institution. They want to provide data to researchers and for some external organizations who are, again, doing research on diseases. Now, what's taken them a long time, as I mentioned before, is the ability to leverage this data to develop insights. And this kind of new tool that's emerging in the marketplace that you may have heard of called a data catalog. And this allows users to discover what data is out there by cataloging all the data assets out there. And so what we're moving toward now is this data as a service. And this is something that we're currently trying to build for this one hospital. Is you let the researcher come in and say, oh, I need certain kind of data on blood types of patients for X number of years, etc. And rather than ask IT for it, you would be given this environment where you yourself can find out where that is by using Google type searches, etc. And to simulate the cloud environment, there are vendors out there, and I've listed some of them here, that can provision your CPU, your GPU environment, your storage environment, however much infrastructure you need for your research. So hopefully in a future session, I can report back on the gains that they have made by implementing this. Now, one of my backgrounds is I've been an enterprise architect, a cloud architect, and what I find is it's very useful, if not very important, to define what is your AI strategy before you dive into all this technology solutions. And if you do this, you'll save costs, and you'll be able to kind of consolidate, or at least have some kind of management of all your investments here. And the best practice is to define a strategy. And I've had the opportunity and privilege to work with a number of institutions in Canada to do this. And this is actually an offering we do at no charge. We can't do too many at the same time, but again, those institutions have shared with us what their visions are. We help them define what is the art of the possible and how is it that you're going to get to that art of the possible in the next 2-3 years, etc. This is one of our secret sauces that I use with a number of our institutions, UBC, for instance. So we have a lab in Austin, which we call the HPC and AI Innovation Lab. And there we have a supercluster of Intel, a supercluster of AMD, a supercluster of NVIDIA GPUs. And we allow our customers to use these facilities at no charge, but for a limited time, to help them better understand what is the best configuration out there to optimize their research algorithms. And that's what we did with UBC. Here's my last slide before opening up to Q&A, is what I would call the best practices here. And I think the first thing I would recommend is you really have to adopt a data-driven culture, that it's important to treat data as an asset, and you want to share this. You do not want to silo this and just kind of keep it for yourself. You'll get more value of the data the more you share it. And to have a business-driven architecture approach, beyond like this is neat technology, but what is the value that you're trying to drive in using AI, etc. So with that, let's stop here and we can open up for questions here.
Bill, that's fantastic. We have a few minutes here for questions. If you can stop showing your screen so that I can back in with my camera. No, not your camera. Keep your camera on. Just stop showing the screen.
Yeah.
Perfect. Terrific. So there are questions that came in during your talk. Continue to ask your questions about the subject. First of all, big thank you for everyone. You share such interesting market trends and research data that's fascinating. To me, it's always a masterclass on actual evolution of AI and the application of AI, in this case, in the context of healthcare. One of the questions has more of a historical tone, and we understand you do not speak for IBM here, but clearly IBM Watson was one of those things that brought AI into the healthcare radar, if you will, of a lot of organizations. And there's a lot of promise about Watson in multiple fields, and the kind of the overall theme and question is, where is Watson today? Where in terms of its deployment, where there are things that didn't materialize and there are things that are still going on. Do you have a sense for what the kind of Watson, or maybe in more general sense, Watson-like technology is at today?
So I have 20 plus years with IBM and very familiar with the Watson tools and components. I've worked in those areas as well. And I think they've had a lot of growing pains. And the vendor that I said I wouldn't mention that claimed that they would cure cancer, that was that. That's something I would not have done here. And they were at the top of the hype cycle. They were also at the bottom of disillusionment when they found that, hey, we couldn't cure cancer. And I think people have reasonable expectations. But here's what the industry says about Watson. If you take a look at Gartner would say that the companies that are going to transform healthcare, all these industries, it won't be the cloud vendors. their skills is really providing infrastructure. What you need are subject matter experts. Certainly the cloud vendors can help accelerate it, but the subject matter experts, these startups, they've got nothing to do with really Microsoft, Google, or IBM. Those are the folks who are going to drive it. And our strategy, and what I would recommend is you partner with the big ones, sure, to deploy, but look for these boutique solutions and find out which ones are going to be right for you. And that's where you're going to get the big transformations. Of course, they'll get swallowed up by bigger companies, but the hyperscalers, just treat them, their expertise is really providing infrastructure. Now, well, I say that, Google has created a healthcare unit. Microsoft is investing just money in healthcare. And IBM has invested in that, although there's rumors that they may sell that. So take it with a grain of salt. One trend I see that I hope will disappear is some of these vendors, I won't mention who, want to own the algorithm. So they want to license every time you use it, or for a period of time. And that's a trend I'm hoping will disappear. I think the institutions want to keep their algorithms. I can understand maybe because you want them to maintain it, but again, it's like the Wild West right now. People haven't settled on what is the optimal way to make money in AI. So I hope that addresses that question. Watson, certainly created the awareness of AI, but as you saw in the Gartner chart, where Watson was positioned, where Google was positioned, where AWS, they weren't in the leaders for developing AI applications. They're certainly visionaries, but the leaders are other companies.
Very well. No, that's great. The concept of data availability and utilization is a big deal, because we understand AI needs large data sets to build its muscles, if you will. Yesterday we had a speaker from the Mayo Clinic talking about all these challenges with patients sharing data and who owns what, and there is very little consensus, especially in North America. In Europe, they have done some things already, but here in North America, we're still playing catch up, and we're having a hard time agreeing on certain standards, if you will, for data sharing and who owns the data. On that note, there is a specific question here that I want to bring up from William Fuller, who has been in the healthcare space for many years as an excellence and innovation leader. And his question is, how do practitioners help their organizations treat data as a shared resource? I find this a huge point of contention and pain, especially in non-leading organizations. What has worked as a change approach with healthcare organizations in your view?
Oh, we could spend a whole session just on that topic. I agree. But here's something that keeps me optimistic. I was working with a hospital out in BC. The technology, the open source movement has gotten to the point where I have seen doctors mandate, I'm going to collect the data. I'm going to create an application that will help direct our resources. And I've seen, these aren't ordinary doctors, but, doctors do have good math training. And this doctor took the time to take an open source kind of algorithm, modify it to kind of reduce time spent in a certain ward, to reduce so they could increase their productivity. But again, this is one person who could do that, and then that helped people see, hey, maybe we should kind of get onto this. So when you're faced with kind of traditional people where I'm going to keep my data, or we're not sharing, or everything has to be here and only these people get access to, unfortunately, what you see, the best way is people kind of breaking off with central IT or the line of business and saying, hey, this is something simple, and try to sell them and say, hey, if you want more like this, you should really try to open up and accelerate this adoption. I'm afraid there's no easy answer against some of those challenges. I agree. lots of challenges out there, and probably the most challenging environment the industry has in sharing data. Not easy, but when you do, the payoff is enormous.
Excellent, Bill. Listen, we are out of time on the session now, but I wanted to thank you for sharing your expertise. And I want to ask one last quick question here. What is the best way for people to connect with you, to learn about the journey that you're leading with Dell, and then be able to draw on your expertise a little bit more?
Folks can contact me through LinkedIn or send me an email directly to bill.wong@dell.com. Happy to answer any questions people have.
That is terrific. Thank you so much. On behalf of our global healthcare audience today, we're very thankful and grateful for having you sharing your expertise and incredible research insights with all of us today.
Thanks, Jose. And again, thanks to all you folks out there in the healthcare industry for keeping us safe.
Thank you. Ladies and gentlemen, that was Bill Wong, leader for artificial intelligence at Dell, a wonderful leader and practitioner of artificial intelligence across multiple industries, and certainly with a focus on healthcare that is very relevant to our team here. And if you take a look at some of the resources that he shared with us during his presentation, there's a lot of depth to those resources. And there is some of the tables where he showed by application what are some of the industry leaders. I mean, he is sharing this so selflessly about, you know, competitors of his own company that are doing great things, and this is where those competitors are best in class. These are the areas of applications that you find the best in class leaders, you know, currently. That is such critical information to get if you are implementing data-driven processes and systems in your healthcare organization. So make sure to check that out and follow Bill's work. He has spoken in our conferences multiple times and always brings tremendous insight. So very thankful for that. Now we're gonna wrap this session up, and at the top of the hour, we'll come back with a leader from Blue Cross Blue Shield of Michigan. Matt Thibodeau is going to be with us to discuss value management and how you get value from your transformations. So a real practitioner on healthcare and understanding how the transformations are good, but transformations must create a new thing that creates value. And so as we transform ourselves and our organizations into a value creation entity, you know, how do you get there? And how do you show that? So tremendous insights from a practitioner in the industry, sharing that directly with us at the top of the hour. So I'm gonna close the session. I'll see you back up at the top of the hour.
Thanks, Jose.